All right, 4.6 Trig Identities. We're looking at the Pythagorean identity. We need to know three identities. The first one is known as the Pythagorean identity. The Pythagorean identity is sine squared theta plus cos squared theta is equal to 1. Another way to write it is sine squared x plus cos squared x is equal to 1. These are known as the Pythagorean identity. You can use the Pythagorean identity backwards or forwards such that we can simplify or change an expression and manipulate it the way we want it to. So PI is one of the identities you must know. This is the only identity as well that I allow students to manipulate one other way. And that way is when you isolate for sine squared theta. Sine squared theta is equal to 1 minus cos squared theta. And cos squared theta is equal to 1 minus sine squared theta. So these are just four ways of writing the actual identities. Sine squared theta plus cos squared theta is equal to 1, or sometimes the theta is represented with a variable, and also these are the other manipulations for the exact same problem. So we're trying to solve, using Pythagorean identity, some sort of problem and be able to prove that left side equals right side. Now, next part. Quotient identity. The quotient identity, also known as QI, involves tan. Sine theta over cos theta is equal to tan theta. Sine x over cos x is equal to tan x. This is another identity that you can use. We use this usually to express tan in terms of sine and cos, and you'll see why in a little bit. The reciprocal identity is the last one. This one you should be familiar with based on our last lesson. The reciprocal identity is cosecant x is equal to 1 over sine x, or cosecant theta is equal to 1 over sine theta. Secant x is equal to 1 over cos x, and secant theta is equal to 1 over cos theta. Cotangent x is equal to 1 over tan x, and cotangent theta is equal to 1 over tan theta. So the idea here is that we're to express all of the reciprocal identities in terms of sine and cos. So the reciprocal ratios, cosecant, secant, and cotangent in terms of sine, cos, or tan. Now, keep in mind that 1 over tan x can be simplified even further, that if we use the quotient identity and flip the actual the quotient identity, tan x equals sine over cos, flip it, and that will equal cotangent x, which is cos over sine. Note, everything must be converted in terms of sine and cos. If you remember this one simple rule, I guarantee every identity you prove can be proved rather quickly with very, very little confusion. So, keep in mind that the idea is that you work with the side that doesn't have sine or cos and convert everything in terms of sine and cos. Example number 1. We're going to prove that tan squared theta plus 1 is equal to secant squared theta. We're going to do this by converting in terms of sine and cos. Using the left side. Now think of the equal sign that you see up here, this equal sign. Think of that equal sign as our barrier. You cannot move across here. We can't move anything across there. It's kind of like the idea of the Berlin Wall before it came down. East and West Germany, it was the wall that nothing could cross. So therefore, we're going to treat that in that way. So we have tan squared theta plus 1 is equal to secant squared theta. We're going to work with the left side only, the left side of the equal sign. Tan squared theta plus 1. We're going to convert tan squared to sine squared over cos squared. And then we'll leave the plus 1. And we're doing this using something called the quotient identity, or QI for short. Anytime you use one of the three main identities, PI, QI, or RI, you have to make sure that you list the identity you use. So, looking at that particular left side right now, we see that we have a fraction plus a whole number. If you remember from Unit 2, anytime you saw something like this, your automatic reaction is to find a common denominator. Our common denominator is going to be cos squared theta. So on the bottom, we will have cos squared theta. On the top, we will have sine squared theta plus cos squared theta. Why do we have that? Well, folks, it's because 1 needs to have a common denominator. That will be cos squared theta. So 1 is represented by cos squared over cos squared. We have that. You should notice on the top, automatically, woohoo, we see sine squared theta plus cos squared theta. We have something that we know we've seen before. Remember that sine squared plus cos squared is actually equal to 1. 1 over cos squared theta, and we use the Pythagorean identity. So you must list the pi. Finally, look at 1 over cos squared. I've seen that before. Well, 1 over cos is equal to secant. So 1 over cos squared is equal to secant squared theta. That comes from the reciprocal identity. So in one example, we've used all 3 identities so that the left side equals the right side. The idea is that you have to simplify it, manipulate it, using the identities and without using a calculator. All right, example number 2. Now, let me just go over how to identify all the pieces. The first part is that we use qi to convert tan squared over to be sine squared over cos squared. That was using qi. The second step was to find a common denominator. The third step was to take the numerator and use pi and use it backwards. So instead of sine squared plus cos squared, we would write the number 1. And finally, the last part was using the reciprocal identity. Example number 2. Prove that 1 minus cos squared theta is equal to sine theta, cos theta, tan theta. Now, I know that you already have a reason for 1 minus cos squared theta, but I don't want us to touch it just yet. Okay, I know we have one for the left side, but look at the right side. The right side is more confusing. The idea is we work with the harder side. So the right side is what we're looking at now. The right side, we have to convert. What are we converting? We're converting the tan theta. Using qi, we find out that sine theta, cos theta, times sine theta over cos theta. You should see automatically that something can be canceled. Yes, folks, we can assume the restrictions have been in place so that the denominator cannot be 0. Cos theta can be divided by cos theta, such that we're left with sine squared theta. If you look on the left side, we have 1 minus cos squared theta. Let's say we forgot that 1 minus cos squared theta, using pi, is equal to sine squared theta. Let's just imagine that we forgot that. Another way we could approach 1 minus cos squared theta is to write 1 in terms of sine squared plus cos squared, minus cos squared theta. And that turns out to be actually sine squared theta. So sometimes you can manipulate both individual sides to get the answer that we're looking for. What we could have done on the right side originally was to convert that sine squared theta to 1 minus cos squared theta using pi, and lo and behold, that will equal the other side. It's just a thought, folks. I just wanted you to see different variations of the same type of problem. All right, example number 3. Prove that sine theta over 1 plus cos theta is equal to 1 minus cos theta over sine theta. So, what do we do here? Remember that we cannot cross multiply because that equal sign operates as a barrier. It is the Berlin Wall. It is no man's land. It is the idea that nothing can come across that equal sign. So we must work with one side. Let's work with the left side. Left side, you have sine theta times 1 plus cos theta. That's the left side. What can we do? Well, if both of these fractions were on one side, we would find a common denominator. So the idea is to manipulate both sides by multiplying by a magic number 1. The idea is that we can multiply anything by 1. 1 times anything remains the anything the same. So the idea is that anything can be 1 as long as the numerator and the denominator have the same values. So what we're going to make 1 this time is the denominator of the second fraction will be our 1, so that it's sine theta over sine theta. That sine theta over sine theta is the magic 1 that we're looking for. But we don't want that magic 1 because what we want to do is multiply across. So instead of trying to cancel, which would be silly because we'd get back the original question, what we want to do is multiply across. So we're going to take sine theta times sine theta, and on the bottom, we're going to take 1 plus cos theta times sine theta. Now, what we can do is multiply the right side by the same magic 1. But this time, our magic 1 is going to be the denominator of the other side. So 1 minus cos theta times sine theta is going to be multiplied by 1 plus cos theta over 1 plus cos theta. Remember that I said 1 can be anything. Anything such that the numerator and the denominator have the same value. So I can take the numerator, 1 minus cos theta, and multiply it by 1 plus cos theta. And that will give us the following denominator on both sides. Note the left side and the right side now have the same denominators. That's a goal, because if they both have the same denominators, somehow we'll be able to find the same numerators. In the left side, the numerator is going to be sine squared theta. On the right side, you're going to expand this using FOIL to have 1 plus cos theta minus cos theta minus cos squared theta. So let's see that again. 1 plus cos theta minus cos theta minus cos squared theta. So once we do that, you'll notice that the cos thetas will cancel each other out. They subtract each other away. So cos theta minus cos theta is 0, and you're left with, in the numerator, 1 minus cos squared theta. Well, folks, if you remember pi correctly, you'll remember that 1 minus cos squared theta is actually equal to sine squared theta. Using pi, and lo and behold, guess what, folks? We found that the left side is equal to the right side. Cool. All right. Example number 4. Let's just wait and watch the next video.